So let us go ahead and talk about pointer syntax as it pertains to single-dimensional arrays. So here we have a single-dimensional array, and it's comprised of three elements, 1, 2, 3, and it's able to hold a bunch of ints, basically. So if you remember, we're able to also go ahead and visually represent a single-dimensional array using a tree kind of visual, which we have a root, and then we have all these branches, and these indexes right here, 0, 1, 2, will allow us to go ahead and get access to the various elements. Now what I would like to do is I'd like to go ahead and take this visual right here that we talked about before and actually expand it out such that we can actually see the addresses behind the scenes. So if we were to go ahead and just take this visual, which has the root and all of its elements, it would look something like this. So here's the root, and here are all the elements. Let's not worry about this other piece right here. So there is the root, and there is all the elements. So we have three elements, which is the 10, 20, 30, and each one of them is an int, of course. And so 10 is sitting in location 1000, 20 is sitting in location 1004, 30 is sitting in location 1008. Now, what is interesting about an array is that the memory slots here are in consecutive memory locations. So if we assume, for example, that each int takes 4 bytes, if the beginning of the array is in location 1000, then we can be sure that the next location after that is going to be 1004, because 4 bytes is the number of bytes that an int takes. And then the next location after that is going to be 1008. What is also interesting is that if you were to go ahead and take these indexes, which is 0, 1, 2, having the very first location, which is that 1000, if we were to go and add just 1 to it, this 1 right here would be really 1 int. So 1000 plus 1 int, which is equivalent to 4 bytes, would give us 1004. 1000 plus 2 ints, 2 times 4 is 8, would give us 1008, which would actually go ahead and get us to this spot. So you notice that these indexes right here are used to go ahead and add a certain number of bytes to the base address. Now you also notice that we have this piece right here, and this piece right here in a sense is kind of like a pointer variable that contains the beginning address of where the array is beginning. So the array begins in location 1000, and here we have this kind of variable that is containing that beginning address. So if I was to go ahead and, actually let's go ahead and change that. If we were to go ahead and take a look at this array right here, so array in itself, just the name, is going to go ahead and point to this box which contains the beginning address. And that beginning address, of course, is coming to us from the very base first location of where the array begins, and then we just go ahead and move on further. And of course the reasoning behind that is that if we have the beginning address, then we can figure out all the other locations by just adding the index, which of course would represent a certain number of bytes depending on the actual type itself. Now I should mention that all of this structure right here is held together. That is, unlike the other contents that you could actually change with regards to arrays, the only contents that could be modified is this one, and this one. This one right here cannot be changed, and of course the addresses cannot be changed either. And the reason why this cannot be changed is because we need to actually go ahead and use the name of this variable, which is array, to identify where the base location of the array is. And if we were able to go ahead and modify this, then all of a sudden we would go ahead and lose our reference to where the array begins. So once again, in this context, within the context of the arrays, the content area of the root cannot be modified. So having that, we already know how to go ahead and get access to all these different elements. So we know just the name by itself is going to go ahead and give us this base address. Which of course is the beginning point right there. We know that we could use the old notation, so array of 0, array of 1, array of 2 will go ahead and give us those. And we also know that we could actually go ahead and use the ampersand to go ahead and get access to the addresses. So ampersand array of 0 is going to go ahead and give us 1000, ampersand array of 1 is going to give us 1004, so on and so forth. Now, these are not the only notations that are available to us. We could also go ahead and use a pointer notation, as we'll come to see. So, if we were to go ahead and take the 1000 and add 0 to it, the 0 would say, well, just add 0 bytes. And that would actually go ahead and land us right there. So array plus 0 would actually land us right there. Array plus 1, that's 1 int, which is equivalent to 4 bytes. So 1000 plus 4 will give us 1004 and would land us right there. So we take the array plus and then the index, and that would actually go ahead and land us in one of these locations right there. Now, if we want to go ahead and use this other notation to go ahead and move on over to the content area, we could say, alright, so I have array plus 0. I go ahead and take this whole thing, wrap it in parentheses, and I prefix it with an asterisk. So, the basic rule is this. We go ahead and take the stuff from the previous column, which is, of course, array plus 0, array plus 1, array plus 2, wrap it in parentheses, and prefix it with an asterisk. Or, if it has a plus, we'll just go ahead and take whatever is sitting in the previous column, and then plus whatever the index is. So we're either using a plus or an asterisk. With a plus, we add the indexes. With an asterisk, we go ahead and wrap it in parentheses and prefix it with an asterisk. And really, this notation should make sense. So, for example, if we have array plus 1, which lands us right there, then the asterisk says, all right, why don't you go to location 1004, which is where we are, and tell us what the content is, which is going to be that 20. Or array plus 2. Let's go to location 1008, and then if we have an asterisk right before it, then it says, tell me the contents of what is sitting in that location. Now, we have to be careful to make sure that we wrap this in parentheses. That is, we need to go ahead and do the addition to make sure that we're sitting in that location, and then finally go ahead and use the array notation to get a hold of it. Now, one thing that we need to keep in mind here is that we're also able to go ahead and point to an array. So this 1000 right here, of course, is coming from here, and this 1000 is really nothing but just the address of an int. Well, if I wanted to go and store the address of an int in a variable, what kind of a variable would it be? Well, there it is. It's a variable that's able to hold the address of an int. So this 1000, which is the address of an int, there it is, array, is being held in a variable that's able to store the address of an int. So there is a variable now that's storing the 1000. So notice that now we have a couple of different routes to go ahead and get access to the array. We can use this pointer or a variable, or we could actually go ahead and use the array. Now, the only difference between these two is that the array is a structure where all of this is intact and it's held together, and we're unable to modify this location. Whereas with this variable right here, its whole purpose is to go ahead and store addresses of ints. So whether it's the address of this int, the address of that int, or the address of this int, it doesn't really make any difference. It's the address of some int. So this is changeable. And of course, now having this, once again, we could just say pointer array plus 0, pointer array plus 1, pointer array plus 2. So we could use all of this syntax that we have seen here and instead use ptr as the variable name. And all of this, of course, is interchangeable. So we could actually go ahead and use this syntax or this syntax, and they would mean the same. And being that, once again, we're storing the beginning address, the base address of the array, we are able to go ahead and use the same syntax with this pointer variable. Now, just expanding on this for a moment, let us say that we want to go ahead and pass an array. Now, we already know how to go ahead and pass a single dimensional array, but now it should make more sense. So if we actually have this array and we are passing the array, so array is really this location right there, which is the 1000, which is really this 1000, which is the address of an int. So we're sending on over the address of an int. So we need to go ahead and send on over the address of an int. Well, what kind of a variable must this be to be able to hold the address of an int? Well, there it is. It has to be a variable that's able to hold the address of an int. Now, previously, we had used this other syntax with the 2 brackets or leaving this empty. And this now is indicating to us that all of this is really the same. That is, this is really nothing but a pointer variable. And notice that we actually had the option to leave this empty, which of course is the very reason why we're able to get away with just having a plain asterisk with no number appearing, because we don't really care about the number, and that is optional. You will also notice that this syntax that we are using, which is array and int asterisk pointer array, is the exact same thing that we're doing in the assignment statement. So int asterisk pointer array, int asterisk pointer array equals to array, equals to array. So this is that same concept that we talked about, which is when you're actually doing an assignment, if you know how that process works, then passing things into a function is exactly the same thing. You're merely just assigning a value to a variable. You're assigning a value to a variable, and it's all the same thing.